Okay, then now I want to give you another MS. That is MSE. You know the MS stands for the mean square. It's a mean square. I told you it is another kind of the variance. And the E is the error. It's before is MSTR, that is the mean square treatment, right? It's a between. And now I can interpret it is a within. It's the same thing. MSE from SSE and degree of freedom. So we are going to discuss the SSE first. It will be the double summation. Yeah, always it is a double summation. And it is a sum of square, right? It's a double summation of square. And now, briefly, I explained to you, it is a within. You know, before we had as many samples. It's actually the K samples. It's a sample 1, 2, and K, right? And we took the X1 bar, X2 bar, XK bar, and we found the SSTR, and I interpreted it as between. The between groups. So we just take the overall mean, and between groups, we take the sum of square, we take the variance, we take the MSTR, right? But now, what? Now it must be within. That means we are going to take another variation in each sample within. So it will be the SSE. So now I have to plug the Xij. Each case, each observation in each sample. Minus, we need the variance inside, right? That means we just take the center and we take the variation, right? So we subtract Xi bar. So please try to understand why we have to take the difference this way. Because we need another variance inside. It's within. So maybe we have a x11, x12 up to x1n1. Then now we are going to take x1 bar. Is only in sample number 1, and we are going to take the distance square summation again. So it will be the inner, the inside, the variation. How many? We are going to take the K summations, I mean the K inner summation. Absolutely, the inner summation, the index is J from 1 to Ni. So now I can say this one is the within variation. And just to sum up the within the variation. Okay, so it will be SSE. Okay, then now we need a degree of freedom. How? We just count how many, and we just count how many, and take the difference. Okay, now tell me, how many xi's? You know the xi's is a general notation for each observation, right? So overall, how many sample size? Can you remember the notation for the, in each is N1, N2, Nk. But what was the notation of the summation of ni's? It was big N. Big N was the overall total number of observations, right? So I can explain, we had capital N xi's. Another way, I have a capital N observations, the total number of cases. Now, here's the xi bar again. How many? From each, we had k xi bars, okay? Additionally, we got x bar. It was only one. It's a single statistic, x bar, the overall mean. But now, the second one is the sample means from each sample. So that will be k. So simply I can say, let me take the double summation, xij minus xi bar square. How many degree of freedom? It's a capital N minus k. So it has another degree of freedom. And we name it mean squares error, MSE. So now we have two kinds of MS. The first one was MSTR, and the second one now it is MSE. So we need the two MS. We need the two kinds of the variances. MSTR, that is the between variance, the between groups, right, this way. But MSE is inside, yeah, this way. So one is the horizontal way and the vertical way. Yeah, we need the two kinds of the variations. But remember, what was the null hypothesis? Now, we want to compare the population means, right? So please remember, the null hypothesis is mu1 equal to mu2 equal to is up to mu k. What we are doing? We are discussing the ANOVA. In ANOVA, we compare the means, the K means, K unknown population means. But what does it stand for? ANOVA? It is the analysis of not mean, but variance. Very interesting. We are comparing K population means. We want to compare population means. But what is the title? Analysis of variance. Why this not analysis of means? Why this the analysis of variance? Because we are going to use the two variances. One was MSTR. Another variance is the MSE. I can interpret it is the variance. It is a variation between, and MSE is another variation within, inside. So because of that, simply we use the variance, MSE, MSTR and MSE, but remember, we want to compare the population means. Okay, yeah, so be careful.